We're going to end chapter 5 with some various statements about proportionality, setting up proportions. And here's just an example of things that are divided proportionally. Suppose you have 3 children and they have a joint savings account, and every month that the child has been alive since birth, they put the same amount in for every child since they've been born, okay? They have 3 children. But let's say one of the children is just 2 years old, the other child is 4 years old, and the other child is 6 years old. Well, not surprising, the 6-year-old, they've been putting money in every month for 6 years, whereas for the 2-year-old, they've been putting money away every month for just 2 years. All right, so let's say that the total in the account is $7,200. Remember we talked about if they're divided proportionally, but there's an unknown value, you represent that as an X. The 2-year-old would get 2X. The 4-year-old would get 4X. And the 6-year-old would get 6X. And those added together is going to make $7,200. All right, so let's see. 2X and 4X is 6X. 6X and 6X is 12X. Equals 7,200. Divide both sides by 12. And you're going to get X is equal to $600. So the 2-year-old, if it's divided proportionally, the 2-year-old will get $1,200. The 4-year-old will get $2,400. And the 6-year-old will get $3,600, and that totals up to $7,200. So this account has been divided proportionally. The larger number, if you will here, gets the larger amount. So expressed as a proportion would be $1,200 for the 2-year-old, $2,400 for the 4-year-old, $3,600 for the 6-year-old. These are all equal because this is going to equal 600 over 1. This can be reduced to 600 to 1, and this can be reduced to 600 to 1. In other words, they each got $600 put away for them per year. So that's kind of a real-world example or a finance example. Let's look at what we mean by proportionally divided when it comes to geometry. We can talk about line segments. We can talk about angles being divided proportionally. Here we're going to talk about line segments. The phrase divided proportionally. So here I have segment AC with point B on it. Here I have segment DF with segment E on it. And they say that AC and DF have been divided proportionally. That means that, now you have to make sure you get, that you're consistent. The length of AB is to the same, AB is to DE as the shorter part, BC is to EF. That's one way to set up the proportion. Piece is to piece as piece is to piece. There are many ways you can set up this proportion as long as you are consistent with what you put in the numerator and what you put in the denominator. Let's look here. Here we have a pair of segments that are divided proportionally, not just at a single point, but at several points. So here we're told that we have RW segment and HM, and the phrase is they've been divided proportionally. That tells us that the length of RS is proportional to the length of HJ. Oh, sorry, I didn't want to There was a 4 under there. I don't want to get rid of the numbers. That means the length of ST to JK. You can see the proportion. This is an extended proportion over here. So in other words, 6 to 4, that is going to be the same as 12 to 8. That's going to be the same as 15 to 10. That's going to be the same as 9 to 6. And if I were to reduce this, that would be 3 to 2. Reduced by 4, that would be 3 to 2. Reduced by 5, that would be 3 to 2. Reduced by 3, that would be 3 to 2. You see how they are in proportion. They've been divided proportionally. So that's segments divided proportionally. What about if sides of polygons are divided proportionally? You just have to set up your proportion correctly. So here we have triangle ABC. They never named triangle ABC, but we are told that AB, side AB or segment AB and segment AC are divided proportionally by segments D and E. They tell us AD is length 4. They tell us DB is length 7. They tell us EC is length 6. And they want us to find AE. Well, if they are divided proportionally, 4 is to X as 7 is to 6. The product of the means is equal to the product of the extremes. Divide both sides by 7. And we don't get an exact number. We want to leave it as an exact number, 27 over 4. If you wanted an estimate, it would be about 3.43. But since we're talking about proportions being equal, I think I would leave it as a fraction there. Okay, another property of proportions is if a proportion is set up and it's true, you can add the numerators and add the denominators and get a third fraction that has the same proportions as the original two fractions. It's kind of a little trick. So here I have 2 is to 3 as 4 is to 6. Well, they are proportional, aren't they? That's a true proportion. So let's add the numerators. 2 plus 4 is 6. And add the denominators. 3 plus 6 is 9. And you know what? If we were to reduce this, this would be 2/3, which is what the original two ratios are also. So you can add the numerator and add the numerators and add the denominators. Or if you wanted to keep the numerator on the left-hand side, you can actually add that term to the numerator. If you wanted to keep the original denominator on the right-hand side, add that to the denominator. So if I have 1/2 equals 5/10, I could add a 2 there, and I could add a 10 there, and I would get 3 over 2 is equal to 15 over 10, and they are equivalent. The proportion is still true. So if a line is parallel to one side of a triangle, and if it intersects the other two sides, the sides are going to be divided proportionally. Here's a triangle. If I intersect with a line or a line segment and these are parallel, I'm going to set up, they'll be divided proportionally. A is to X as B is to Y, or you could say A is to B as X is to Y. As long as they're parallel, I'll mark they're parallel with the arrows there.